So a suitable substitution for this one, let's make, so on the bottom we have the square root of x squared plus 1, and if we had the square root of tan squared theta plus 1, we know that would equal the square root of sec squared theta, which would just give us sec theta. So let's make x equal tan theta. Then we would get dx being sec squared theta to theta. All right, if we change the limits to theta, tan 0 is 0, and we don't have anything nice for root 2, so we just put inverse tan of root 2 there. Now we know x cubed, so if I just write x cubed is tan cubed theta, so that's made up of a tan theta and a tan squared theta. So tan theta and 1 minus, sec squared theta minus 1, sec squared theta minus 1, there. So that's what we're going to put instead of the x cubed. So sec squared theta minus 1. Now you can see on the bottom we're going to have our sec theta. And from here, dx equals sec squared theta to theta. So if we just simplify that, one of those will go. We're going to get tan theta, sec squared theta minus 1 to theta. Alright, and we've still got our limits up there. Okay, so now this is looking a bit crazy. So what we can do is do another substitution. We don't have to, but we can if we want to make it a little easier. Let's make our u this time equal sec theta, and why would we do that? Because we know that du is tan theta sec theta. Alright, so if u equals sec theta, du equals tan theta sec theta to theta. And we've got tan theta sec theta to theta. So what we can do is all this section just becomes du. And then this would be u squared minus 1. Of course, we need u limits. So if I put in 0, okay, so if this is difficult for you, just remember that you could always use a right angle triangle and put a theta there. And using the fact that tan theta has to be root 2, we can go their old age, so root 2 over 1. And then your third side using Pythagoras would be root 3. So if we're looking at sec is 1 on cos. So let's just go cos for a second. So cos can't always hide, will be 1 on root 3. So we know that sec theta would be root 3. So that hopefully will help us. So first of all, 0. If I put 0 in, I know that cos of 0 is 1. So sec of 0 is 1. So that's going to be 1. And sec of theta in the case of this upper limit is going to be root 3. Alright, so it should be fairly easy now. We just have to sub in root 3. So root 3 to the power of 3. Well, root 3 squared is 3, and then there's another root 3 there. So we've got that minus a third minus 1 if we sub that one in. Alright, so what do we get then? We get 3's cancel, so we get root 3 minus root 3 minus a third, but plus 1. That'll be 2/3. Alright, so we're going to do that same question, but I think it's an easier way. Oops, let's go back up. So now we're going to do that same thing, but this time using just algebra rather than that substitution there. So algebraic manipulation. So our x cubed, let's just have a look at that. So x cubed on square root x squared plus 1, we want it to kind of look like the bottom. So let's make x squared plus 1. Oops. If we use x squared plus 1, because there's an x squared plus 1 with a power of a half, but that's okay on the bottom, we would have to times by x to get the x cubed, but we've also got then a positive x that we need to get rid of. So we also have to minus the x there. So that would become x, so 1 minus a half using index laws would give us that for the first fraction and this for the second fraction. All right, so we're just breaking it up. So let's break up this integral now. So 0 root 2, if we think about it, the derivative of the x squared plus 1 is 2x. So actually, let's put a half and make it have a 2x. There we go. Might make it easier. And we'll do the same for the second part of that, second fraction. So we will have a 2x. So the derivative is there if we need it. All right, and we might do, you can do it in your head, or you can say, let's do a substitution. Let's make u equal x squared plus 1. So du equals 2x dx. All right, what would that give us? So we'll have a half here. Our 0, if we put that in, will become 1. Our root 2 will become 3. And our 2x dx is du, so we end up with u to the half du for that one. For this one, so we're going to have the same limits. Here, again, our 2x dx becomes our du. So we end up with u to the minus a half there, just nice and easy. So you could do that in your head or make the substitution. So we've got the half out here. If I integrate, I'm adding 1, so I get 3 on 2 divided by 3 on 2. And that is between 1 and 3. Minus half here, I'm adding 1, so I actually get a half divided by a half. And that is between 1 and 3. I don't know why I've got a root 3 there. Alright, so of course the half and 2 cancel. So I'm just subbing in a 3 to, okay, so we end up with, so we'll have a 3 root 3 on a 3, so that's 1.5, minus a third. And then we've got over here, we've got minus, they cancel, so minus. Here I'll put root 3 minus root 1, which is 1. Alright, so they cancel. So I've got root 3 take away root 3, so 0 there, and negative a third plus 1. So we're going to end up with our 2/3. So in some ways that's much easier than dealing with trig. And there are other ways as well.